Alright, so let's go to HTTP. And here we will talk about 5-6 things. First we'll talk about what is HTTP, how does a sample web page written, what are the messages, what are the cookies, what are the proxy servers, what is the conditional get. So basically HTTP, HyperText Transfer Protocol. P stands for protocol. Hypertext. So before there were web pages, there was hypertext. What was hypertext? In the old days, before 94, you could have plain text, or you could have hypertext. In hypertext, there were some words that you could click on, and if you click on those words, it will tell you more detail about that word. Right? So that existed before. However, this guy whose name was in the previous slide, what is his name? Berners-Lee or something. Berners-Lee. He came up with the idea that when you click on something, it doesn't have to be on the same computer, it could be on some other computer. That was his innovation. So he extended hypertext from a local information to global information. So now he said, oh, you can write a page and you click here and then you can reach that other place, get the information from there. So that is well, actually that is called hypertext. And now you write in a language called HTML. HTML is the language. L is for language. Hypertext, what is M for? Markup language. All right? So, talking about the HTTP, there is a server, and when you want to get a page, you send a request, which is called HTTP request, and you get HTTP response. Somebody else who is running another computer could send an HTTP request and get an HTTP response. They could be running very different programs. This guy is running Internet Explorer, this is running Navigator, Firefox or something, doesn't matter. But all of them generate the same message. The interface, the user interface could be different, the operating system could be different, but the messages are exactly the same. So the server gets the messages and knows what you are requesting and sends you a response. Responses are very similar, are same, and then they are displayed on your computer according to your computer screen size, according to your whatever you have. If it is a little iPhone, it will be displayed differently than if it was a big 42-inch screen. So anyway, HTTP server is written by Microsoft or Apache and so on and so forth. And web page, now what is a web page? So web page itself is a whole group of objects. It could have some text, could have some pictures, could have some movies, all into the page, right? So we call them objects. These objects will be text, images, and files. And each web page has a URL. URL is the locator, Uniform Resource Locator. So that URL tells you where the page is located. For example, when you say http://www.cse.edu/jan/CSE4973 blah blah blah. This is a URL. You already know that. But what you should know now is that the first part here is the protocol. So to access this information, you need to use this protocol, not FTP. You could probably access something else with FTP, so that would be FTP:something. Second thing is, this is the name of the computer on which it exists. Third thing, this is the name of the directory in which the information exists on that computer. And this is the name of the file. Now, this first part is case insensitive. So you can write in uppercase, lowercase, mixed case, it doesn't matter. But the second part is kind of very confusing, because it could be case sensitive, could be in case insensitive, depending upon the operating system of the server and of the client. All right? So you just have to copy it exactly. Because if you type something, I type in lowercase and you type in uppercase, your operating system may say file doesn't exist. Okay? So the directory names and the file names are case sensitive, and the computer names are case insensitive, the protocol names are case insensitive. Okay, because when you're reaching a computer, you have to tell it what computer you're reaching and what port number you're reaching. and what protocol you're going to talk to it about, right? So actually I'm missing one thing here. I could have put here :80. After edu, I can put the port number. So that tells me that I want to reach this computer on port 80, and then I will, after I connect, now this you are telling the TCP, that after I connect, I want to talk HTTP, so then TCP will, now TCP is serving many applications in that computer. It is serving an FTP server, it is serving a web server, and so on and so forth. So it has to know which process to give your packet to. So that first word and the port number tells what protocol you will be speaking and what port number. Okay, so it is important to put that HTTP. Now, having said that, the browsers today are very smart. If you forget to write HTTP, they can fill in for you. As long as you write www, they know that www is generally for web service, so they will fill in HTTP : / for you. In fact, now, I mean, in this latest version of any of the browser, you don't have to write anything, you just write Raj Jain, and they will look up, they will do the Google search, and they will find it. And they will put in right there. But that is not part of HTTP as it is just browsers are doing it for you. So far, main thing was that you have to understand that HTTP is a protocol, and that you need a locator to get to the server, and then the web page. So now HTTP. HTTP is a protocol which uses TCP. So that is first thing to know, that it doesn't use UDP. Everything that is sent either direction is acknowledged. Second important thing to notice is that the web server is stateless. So when you ask it something, it gives you the answer, but then it doesn't remember what you had asked and what the answer it gave. Second time you go to it, it doesn't know that you had already asked this thing or what it is, right? So that is the original design. The original design by Berners-Lee said that we will not keep any state in the server, and that makes the server really simple. All right? But later on, as we get to real world, we found out that the server needs to know that you have bought this thing and this is in your cart, and that, you know, this is you, and so on and so forth. So then they started cookies business. So we'll talk about how the cookies work. But until we come to the cookies, the servers are stateless, so they don't remember about any request they served, anything. Third thing is non-persistent. Initially, when the servers were designed, they set up a TCP connection for every single object. So on a page, you have a text, you have a picture. Let's start the simple page, text and a picture, and maybe 5 pictures. So there are 6 objects, text and the 5 pictures, right? So you will make 6 TCP connections. First TCP connection to get the text, close the connection. Second TCP connection to get the picture number 1. Third connection to get picture number 2. So that was called non-persistent TCP connection. Right? Soon we figured out that that's really waste of time. In the beginning it was okay because there were only one kind of objects and there were 1 or 2 objects on the page, but now the pages are very complicated and there are lots of objects, so there is no point in setting up a TCP connection for every object. Why don't we just set up a TCP connection and send 50 objects and everything that we need and then close it? So that is called persistent connection. All right, so non-persistent and persistent. So most of the recent implementations, so here the HTTP protocol has version numbers, version 1, version 1.1, version 2, version 3, version 4, version 5. Just like HTML has many version numbers, HTML version 4, 5, and so on and so forth, right? HTTP is different, right? HTTP is a protocol, HTML is the language. So HTTP version 1.1 onwards, we have persistent connection. That means the server leaves the connection open after sending an object and only closes when you don't ask for anything more. If you don't ask for some time, then they close the connection. Web pages are written in HTML. So let's write a page. Here is a page. HTML, head end, and then body, image, jan.jpg, break, name, Raj Jain, body, / last name. This is a full page, right? If you write this page and you get it on the browser, you will get this picture and this name. Okay? And those of you who have not written HTML, this might be a good idea to write an HTML because it's so easy. There's nothing here except that the header and then the body and then these things, like image, source file name, and the text. If you have a browser which is very, very old, many people have programs which are 10 years old. Who knows? If you are using HTTP version 1, then it will be retrieved in 2 sessions. If you are using HTTP 1.1, which is most likely if you have a computer which has Vista and Win 7 or something like that. If you still have, Windows 95, that will do it in multiple sessions. But if you have something recent, it will be 1 session. All right. But for general case, for HTTP protocol as defined, HTTP version 1.1 actually allows and uses persistent connections. Okay. Now, even though it is a persistent connection, the timeout is up to the server. Some servers are so busy that they will time out very fast. Some servers have nothing to do; they will just keep you alive for days. And some servers keep you alive for days just because they want to. Like Amazon. You go to Amazon, buy something today, don't complete the purchase, come back 3 months later, it is still there in your cart because they find it is useful to them. Whereas you go to some other website and you buy something and come back 1 hour later, the cart is empty. Right? So it's all their choice, and we cannot justify any particular person's choice, right? So anyway, so the idea is you can write a web page, and you should write a web page. In fact, if you take any other networking course after this, we will force you to write a web page. That is minimum requirement. And so basically everything that you do today is a web page. When we write a paper, it's a web page. In my website, I have 60,000 web pages. Right? So I got to do this full time. And so this is your life, basically. Okay, all right. So now you know what web page. The idea of giving this is that there are 2 objects here, the text and the picture, and then there's a whole markup. This is called markup. So how do you get this request? So basically, if you wanted to get this web page, you would send a request to the server which says get, and then you will give the directory name and the file name, and you will give the protocol that you are using. Then you will send the next line. And by the way, HTTP is a protocol that uses ASCII messages, not binary messages. So this thing is in English, alphabets. You can type it if you want to from your keyboard straight. So the first message says GET space / whatever, right? The next message says host, actually not next message, the next line, because this could be all one message. Host : that is the host I want to get to. Connection close the connection after giving me that. User agent, I am using Mozilla 4.0 and I accept only English. Okay? You send this message and then you send an empty line. Empty line means end of message. So here what we have said is that, the method is get. This is the method I'm using. URL is actually, now here's the question. The URL is actually not this one. I think URL have to use both the host and the directory combined, but anyway, this is the directory part of the URL. The protocol version is 1.1, and the header field, these things are called header field. Everything before the colon, host, connection, user agent, accept language, those are all the header fields. And there's a colon, real colon there. Okay, so here is the general format. You have to put a method followed by a space, followed by a URL, which is actually the directory name, space, version number, CRLF, carries return and line feed. After that, you have to put the field name, colon, value of that field, CRLF. You keep doing as many fields you want, then you do CRLF. And then if you have something to send with it, then you send that, and then you CRLF. Okay, so this is what the HTTP messages look like. First thing that you learned today is that HTTP does not use binary messages. It uses ASCII messages. And therefore, you can actually, I'll show you in a minute, you can type it in. But anyway, this is the response that will come back. The response that comes back will say HTTP 1.1 200 OK. Connection closed, date, server, last modified, content length, content type, and then lots of data. Yeah.
If you create a persistent connection through a terminal or command prompt, when would that close?
Oh, at the same timeout. It doesn't really know whether you're doing it through terminal or you're doing through Internet Explorer. Whatever timeout is set in the server, it will time out.
Even if you were to close the browser?
Yes, the thing is when you close the browser, the normal thing that the browser will do is it will close all its TCP connections. Right? And so that will close the connection anyway, explicitly. But if you don't request anything, then also the connection can be closed by the server. So any site can close the connection. Okay, so now here's the thing to notice here, that you have the protocol version, and then you have the status code. The computers will not read much of this text, but they know the number, that they are looking for the number 200. Okay? That 200 means good. Everything is perfect, no error. If it is 300, that means there is some problem. If it is 400, there is a bigger problem. And 500 is even bigger problem. So 301 means moved permanently, 400 means bad request, 404 means not found, 500, and so there is a whole list of these numbers. So your browser actually doesn't really read OK. If necessary, it might just flash that OK on your screen, or it might flash this message bad request on your screen or not found on your screen. So that text is for the user. The number is for the browser. Right? So the browser sees the number, and then it thinks, but then it knows whether it succeeded or failed. So that number is important. And those numbers are very properly set. All 200 series is good, all 300 series is bad, 400 is more bad, and so on and so forth, right? All right. So 200 is the best number you can get. Is that clear so far? And these things are very similar. Those something colon is again header field, and then the value header field and the value char is written here at the end, and then data char is written. So a blank line ends the header, and then the blank line ends this thing. Again, the format, message format is same as before. First the version number, followed by space, followed by status code, followed by space, followed by a phrase, followed by character and line feed, and then the header field name, space, value, character and line feed, and so. Okay, so this is the message format. Now you can do it on your computer. What you can do it when you go home, you can try this out. And I did this yesterday, so you can see right here, 13th September. You can sit down on the computer and say telnet www1.cse.boostel.edu port 80. So what you are saying is that I want to connect to this computer on port 80. Then you can say get/join sample stm http/1111. You have to type all this. Now here's the difficult problem. When you type all this, none of this is echoed. So you won't see anything on the screen. It's like your password. The reason it is not echoed is because the web server is told not to echo anything. It just basically, echoing comes because normally when you put something in the computer knows that it has to echo it. It does it, right? But this one is not echoed. So you won't see anything. You just keep typing blindly. And hopefully you type it correctly, because if you make a mistake, you don't know what you typed. Right? One way to avoid that mistake is to put this into the, what they call in the, when you copy something, it goes into clipboard, and then just paste it. And you know how to paste it in DOS, in a DOS box, in a command prompt. Okay? So you just paste it, and then because you already typed it beforehand, and then it will be correct. And that's the only way to do it. All right, so you type this, and then you put a space, line written like that, host, and then that's it. And then suddenly you will see this appear on your screen. What will appear? HTTP 1.1 200 OK, date, server, accept range, bytes, content length 233, connection close, content type text HTML, character set, this and that, and then HTML, head, body, this is sample text, body, HTML. So this file does exist. I prepared this file just for you guys. So this file exists, and this is what this file has. All it has is these 5-6 lines. Right? And if you count the number of characters, it is 233. Okay? Now you don't have to go to my website or anything, you can just go to any website. You could go to google.com, you could go to amazon.com, and so on and so forth, and same thing will work. You could go to boostel.edu. All right? But the interesting thing to notice is that these are the messages, and these are ASCII messages, and therefore you can type it. And that was the whole reason for having ASCII messages. Before this, most of the other protocols had binary messages, like TCP, everything binary. IP, everything is binary. All the old protocols were in binary. And the reason was we were trying to save every bit. But now we don't care for the bits, we care for readability, we care for easy debuggability, so it is much easier to debug with ASCII, human readable messages, rather than computer readable messages. So most of the newer protocols that we use ASCII messages. All right, now if this text was given to a browser, all you will see on the screen is this is sample text. That's all it will show you, right? Because the browser knows how to read HTML and how to present it on the screen. Now you could do this. You could say telnet and get Jains 473-08. Step 11, if you go to 08 sample.html, you will get this thing. All right, this message says HTML head 404 not found, blah, blah, blah. So this is all comes from the server with doc type and so on and so forth. And then the browser will translate that into a screen message like this. Not found, the requested URL sample.html was not found in the server, Apache, blah, blah, blah. Okay? So when something doesn't exist, the server makes up a response. All right? So now we talk about cookies. So why do we need cookies? We need cookies because the servers do not keep any state. Now, if there are many people reaching the server, they might be from the same IP address, some same so on and so forth. We need to know actually what you did before so that we can tell you what to do next. If you want to keep the state, so then people invented cookies. So what cookie is a number that is kept on both sides. Let me put it this way. If you are a client and this is a server, if from the client you send a usual HTTP request to the Amazon, then what Amazon will do is it will create an entry that Mr. Jain logged in at this time, and it will send you a message which has all those previous things that we saw, plus it will have one more header which says set cookie to 1678. All right, and your browser will remember that Amazon sent me cookie 1678. It could have similarly gone to eBay, and eBay would have given it 8734. So there is a whole directory, which is this directory in my case, C:document and settings Raj Jain cookies. You put your name there, go to your computer, and then in that you will find lots of files from many different websites that you have visited in your lifetime. Right? Everything is there. Everybody sends you a cookie and it's all documented right there. So in that directory, all these things are stored as separate files. Or could be one file. That is up to the browser actually. So next time, if you have a cookie, you have to send it back. So the browser, when next time when you send the request to Amazon, then the browser will say, here's my request, and by the way, the cookie is 1678. All right? then it will know, yeah, you are the one who came 2 days ago and you were looking for a computer or Mac or Apple, and things like that. Then it will know all about your history. Okay, so the question was, does the client side just store one number? Here I'm giving an example of a simple one number, but it could be a big number or a big text. It could be 2,000 words. Depends upon, the thing is, they want you to store something that when you send it back to them, they will figure out the whole thing. It could be a very small number, could be a big number, could be a big text. But something that both sides will understand. I mean, actually, hold on. The client doesn't understand anything about the cookies. Client doesn't know what 1670 means, but the server will understand that. Okay, so it doesn't have to be just one small number. Some cookies have everything is stored. So for example, in this case, the Amazon has to have a disk on which they have stored all the cookies they have given to the world forever, right? Right? But that's not a good idea. So what they will do is, they will, in the cookies, they will say cookie, Raj, Jain. And so everything that they need to know about me is in the cookie. And when I send it back, I send it the whole thing myself. I'm telling them, okay, Raj, Jain, I came on December 22nd and I looked for this. All that is in the cookie. Cookie could be a whole big file. All right, so cookie is some piece of information which allows the server to somehow get back to the previous state. And then it will give you the response. All right, when you go to eBay, you take their cookie and send it to eBay. So whichever computer you go to, your browser goes into the cookie area and first looks up and sees if you have cookie from that website. If you have, it sends it. Even if you go up after 3 days, 5 days, 1 month. First thing the browser does is it looks up the cookie. Right? And you can delete the cookies. So for example, if you delete the cookies, no big deal. The browser will not send anything, and then the Amazon will not recognize you. And then particularly if it is your bank, it will come up with a message that this computer we have never seen before. Please reauthorize yourself. What was your mother's maiden name? Right? And then you have to answer all those 5 questions, and then they will put the cookie in. So you understand the purpose of cookies. Proxy servers. So it so happened that everybody is going to the same website and accessing the same information. So some companies thought that why do we have to waste time getting the same information 15 times over the internet, because everything costs money. So they said we will put a server right here in our company. That will provide the answer to all the requests that you might want to get if it has. So it will cache the answers. It will cache the web pages. And if it doesn't have it, then it will send a request and get it, and then remember it, if somebody else wants the same web page, it will give the answer right from its cache. So that is called a proxy server. This is the origin server, this is the proxy server. Origin server is the original piece of information, but the proxy server caches that information and says, this client wants it, it gets it, but this client, it just serves from there. Yeah.
What's the difference between that and just adding another server?
Oh, this belongs to the company, this belongs to the Google or Amazon or something like that.
So the proxy server belongs to the client?
Yeah, this belongs to Wushtel, for example. Because Wushtel is paying for all these messages going out. Any other question? Yeah.
How often does it clear its information?
How often this clears information? This is all basically, huh?
Is the web page where then change to them getting the whole
Okay, so it will. So here, I think this is all up to the person who is managing the web server, proxy server. They can put the timeout, clearing policy, and all that. Now, you as a client have the right. You could say here a message request which says, please reload it fresh. So there is a reload button on the browser. If you do that, then it will say to the proxy server, please get it directly from the origin server. Then it will go and get it, the latest information. Otherwise, you keep typing that page, it comes back to the same old information, because you didn't tell it explicitly that you wanted it from the origin server. So have you gotten into that trouble sometimes, that the page looks old and then you have to reload it? right?
Well, does that caching also happen on your own computer, like on the
Exactly. So there is a proxy server right on your computer as well. So this computer browser has its own cache. And first thing it does is it looks up into its own cache. If it has the information, it puts it right there. If it doesn't find it, then it sends the request, which might be kept by the... Now here's an interesting thing. This proxy server has two purposes. First purpose is to filter out the request. If you type XXXX something, the proxy server says, sorry, information is not available, is not allowed. In this company, you cannot go to XXXX. Period. Right? So any kind of control that the company wants to put can be put into the proxy server. So in many places, it is compulsory that you cannot do anything going out of the company without going to the proxy server, even FTP or anything like that. For example, in many universities, I have been to one university where I had to program proxy server in my computer because they didn't want you to go to places that they didn't want you to go to. No, well, sitting you cannot get out of the company. Sitting if this proxy server is inside the company, this other proxy server is inside the company, then yes, you could get out through that door. But this is almost like a firewall now. So the proxy servers and firewalls kind of, start coming together. Originally, the proxy server were for performance, so that you didn't have to waste money. But then people said, well, this is a good firewall as well. All right, so now you know proxy server. Then they invented conditional get. Conditional get says that please get to it to me if the information has changed. If it is not changed, don't send me the 2 megabyte file. Just tell me that it has not changed. So conditional get is if modified since this date. So your request will have get, and then you will have this header added, if modified since. And you put a date, and then go to the server. Server will check if the date, if this object has been modified. If it is not modified, it will say, sorry, 304 not modified. And if it is modified, then it will say, here, 200, okay, here's the data. Okay, so this saves quite a bit of traffic. So that ends our discussion of HTTP. HTTP is the Hypertext Transfer Protocol. It's a client-server protocol. And so important thing is to notice that it is not P2P, it is client-server. Second thing to notice is that it is text-based messages, things that you can type and read. Third thing is they are written in HTML and uses non-persistent TCP connection generally nowadays. It uses cookies so that the servers can maintain state, and proxy servers are used to improve the performance, and then the conditional get improve the performance even further.